Hello again, we've got another A-level maths video for you here. This time we're looking at the Pure Maths Year 1 content, section 3.4 of the textbook, where we're going to be looking at linear inequalities. And actually something else which we're going to be looking at in quite a bit of detail in this video is something called set notation. So here we go then with an inequality for you to solve. Pause the video in a second and have a go at this one. Make sure you've got your answer before you restart. Okay then, let's see if we can just quickly go through this one together. Do you remember how these work from your previous studies? They're pretty much like equations, right? So here we got 14 is greater than 3x plus 7 over 2, but we can just manipulate this a bit like we would with an equation. Let's multiply both sides by 2. So we end up with 28 must be greater than 3x plus 7. Then the next thing I want to do is just subtract 7 from both sides. And then I'll divide both sides by 3, and we're going to end up with our answer there. 7 is greater than x. So that must mean that the x values that satisfy this inequality here must be less than 7. So that's the kind of thing I've expected you to have seen before. You should be quite familiar with that already. One thing you might not be familiar with is this idea of being quite formal about how we write down that set of numbers. And we're going to introduce something called set notation now for you. This is something which the examiners will expect you to know about, and you may well be asked to write answers in set notation. So on the screen, I've just got a quick example for you to have a look at here. A set in mathematics is basically a collection of objects, usually numbers. And so therefore, if I wanted to write a set, we have to use these curly brackets. And then inside the curly brackets, that tells us we've got a set of something. And the example on the screen here is the set of all positive numbers. So it's written here in this form here, and I just need to explain to you what all the symbols here mean. So the x here is telling us that we're looking at any numbers, which we're going to call x. So this is, all values, which we'll call them x. The colon here, the two dots, we read that out loud as the words such that. Okay, and then the thing after the colon is the condition which has to be true for us to include it in the set. So this is our condition that must be true. So in this particular case, for our positive numbers, we're looking at all the numbers x such that those numbers x are greater than 0. See how it works here. We have the curly brackets to tell us we've got a set. We have the numbers we're interested in here. The condition comes after the colon. Okay. So let's see if you've got the idea here. Question on the screen, which I'd like you to have a quick look at here. Use set notation to describe the set of all numbers less than 100. I've given you some options there. One of them is correct. Okay then, so let me just tell you then that the correct answer for this one is actually the fourth option there. We need the curly brackets to tell us we've got a set. We need to say what the numbers are, and we need to say the condition that those numbers must be true for those numbers here. So the fourth option there, that's the full formal set notation that we must use whenever we're asked to do that. Okay, hopefully that makes sense for you. Right, question on the screen now, which I'm going to ask you to do another inequality to solve. Hopefully the inequality isn't too hard for you here. And just make sure that when you get your answer, you write it in that new set notation, please. So let's have a go at this one ourselves then. So did you get on okay with this? First thing I think I would do if I was solving this inequality is subtract 5 from both sides. We're going to have here negative 10x is greater than or equal to 13. And then I want to divide both sides by negative 10 to just get the x by itself. So if I divide the 13 by negative 10 as well, we get minus 1.3 here. But something which we haven't mentioned yet in this video, which I hope you remembered from your previous studies, is that whenever you multiply or divide any inequality on both sides by something negative, the direction of the inequality symbol reverses. Did you remember that? It's because when you multiply or divide by something negative, basically it kind of flips the order of the numbers. So that means that we have to change our direction here. Now, I've not yet written this in set notation, so let's just make sure that we do that as well, because that's really what we need to be doing here. So I want all values of x such that x is less than or equal to negative 1.3. Put it inside the curly brackets, and I've got my answer in set notation. Did you agree? Okay then. So just on the screen here, just that reminder about whenever we multiply or divide both sides of an inequality by something negative, we do need to remember to reverse the direction of that inequality symbol there. So important. I've put it on the screen there for you here. So please make sure that don't forget that as we're going through the rest of this video, please. Okay, so there's a little bit more I want to say about set notation here, because there are ways we can combine sets together, and sometimes we might need to do that when we're solving these inequalities here. I'll put some definitions on the screen. I'll just quickly go through them here. If we've got two sets, I'm going to call them A and B. We can combine them together in two main ways, really. One is that we can take the union of those sets. Now, that's just really a technical word for saying we're taking everything in set A and collecting it together with everything in set B. And you can see on the screen there's a little symbol we use. The union of set A and set B is written A, and it looks a bit like a letter U between them. A union B is how we would say that out loud. The other way that we might want to combine sets together is we might want to look at what's called the intersection. Now, the intersection is really when we've got values which are in both of the sets, both set A and set B. So if we want to look at values which where they overlap really, where they intersect, that's where that word comes from, then we look at the intersection. And the symbol we use for that is like an upside down letter U, you can see on the screen there. Now, some of you are going to be very familiar with this notation already, but I'm also sure that some of you, this is going to be brand new. So let me give you an example here to show you how we might use this particular idea in practice here. So here on the screen, I've asked us to use set notation to describe the set of all numbers that are greater than 100 or less than 10. So let's look at that individually here. The numbers which are greater than 100 in set notation, we'd write that as the numbers x, such that x is greater than 100. Okay, so we'd write it like that. The numbers which are less than 10, well, that's a different set of numbers. These are the numbers x, such that x is less than 10. Now, we've been asked to combine these sets together in some way because we want to look at the numbers which are either in this set or in this set. So we're looking at all the numbers in this set together with all the numbers in this set, yeah? Because we're looking for the numbers which are greater than 100 or less than 10. So that means we're looking at the union of those two sets. We're not sort of looking at where these two sets interlapped. We're just looking at anything which is in either of these sets. So here's how I might write it down using the notation. I'm looking at the numbers in the first set together with or in union with the numbers in the second set here, like that. And that's how I would use set notation to write my answer to this particular question here. Okay, hopefully that makes sense to you here. Question for you to have a go at, which I put on the screen now. Number x lies between 15 and 20. Use set notation to describe the set of all possible values of x. How did you get on with this one then? So let's quickly go through it together. The number x lies between 15 and 20. Well, what that really means is it's greater than 15 and it's less than 20. So if we write each of these two conditions in set notation, we're looking for numbers x, that's such that x is greater than 15 for the first one. And then the second one are the numbers x such that x is less than 20. Now, are we looking for the union or the intersection? Well, we want both of these to be true. Okay, so we're not collecting all of these numbers together with all of these numbers. We're looking for where these sets overlap. We're looking for the intersection. So we're looking for that symbol there like that. Okay, do you agree? Hope so. Now, before I move on, I just want to say that there is an alternative way you could have written this out. You could have written this out without using this symbol here. You could have written it just as x such that x is between 15 and 20 like this in a single statement. And if you did that, of course, that's a perfectly acceptable answer as well. And you will see that way being used quite often. But here is the way we can do it using the intersection notation of set notation. Okay then, so let's see if we can now just piece all this together, see if we can work out how we can use some set notation to describe solution sets of inequalities. There's a question on the screen which I think I want to go through with you together very quickly, just to demonstrate what's going on. So let's have a look at this one here then. So we've got two separate inequalities, and we've been asked ultimately to find, the set of values of x where both of these inequalities are true. So let's just solve them one at a time and work out the solution sets of each one. So the first one, let's just subtract 2 from both sides. Actually, no, I think on second thoughts, I'm going to subtract 7 from both sides. So we just end up with that x by itself a bit more easily. So we're going to end up with -5 here. And then divide both sides by 5. So we end up with x is greater than -1. So in set notation, that would be the set of values x such that x is greater than -1. Okay, what about the second inequality here? Well, let's add 7 to both sides. So 2x has got to be less than or equal to 10. Divide both sides by 2. We're going to end up with x, which is less than or equal to 5. So in set notation, we're looking for all values of x such that x is less than or equal to 5. Right, so we want both of these things to be true. We're looking for the intersection because we're looking for not just all of these together with all of these. We need both of them to be true. They need to be overlapping or intersecting. So my final answer for the last part is going to be the first set here, x, such that x is greater than -1, where I'm intersecting that with the set of values x such that x is less than or equal to 5. Okay, does that make sense to you? Okay then, so as always, if you do need to go back and re-watch that and think about it a little bit, then please do. But when you're ready, there's a question for you to have a go at on the screen here, which is very similar to the one I've just been doing here. Work out the solutions for all of these things here and use set notation to write your answer for each, please. Okay, how did you get on with these ones? I've just done the first two already. So the 2x minus 9 is greater than or equal to 3x. If you solve that inequality, you can check my working here. But the solution set here is the set of values of x such that x is less than or equal to -9. Hopefully you agree with that. The second one, again, I've done my working here. The solution set to that is this, the set of values x such that x is greater than -3. And in this particular case, we've been asked for the last part to write down the set of the values where either this is true or this is true. So this is when we were collecting these ones together with these ones, we're finding the union of these two sets. So what you should have written down here for the final one is we're looking for the set of values x such that x is less than or equal to -9 in union or together with the set of values x such that x is greater than -3, and that is our set of solutions there in set notation. So just to quickly recap this union and intersection idea then, the word union or the union of two sets is often used when we are looking where one of the things has to be true. So we're either in one set or in the other. Of course, we could be in both, but one or the other. So in English, in everyday English words, that union is really just looking at the word or, one or the other. The intersection, though, is kind of connected with the word and. If we are looking for the intersection between two sets, we're looking for anything which is in both one set and the other set. So in everyday English, you might think about that word and leading you to the intersection here. Okay, but that's it from me from this video here. The consolidation for this one is exercise 3D in the textbook, pages 47 to 48. You're going to get used to doing lots of set notation stuff there. So please do have a go at those questions, and I'll see you again in the next video shortly.